4.3 Orbital overlap and hybridization. At the end of the lesson, the student should be able to draw and describe the formation of sigma and pi bond from overlapping of orbitals. Valence bond theory. Valence bond theory is based on the following four postulates. Postulate 1. A bond is formed when atomic valence orbital overlap with each other. So we have atomic orbital here. Okay. In order to form a bond, the orbital must overlap with each other. Okay, when atomic orbital overlap. So what happened here? Postulate 2. Overlapping orbital contain a pair of electrons. Overlapping orbital contain a pair of electrons. Postulate 3. Electron density concentrated between bonded atoms. Postulate 4. The strength of the bond depends on the degree of overlapping. Covalent bond is formed when atomic orbital overlap. Only two electrons with their spin pair may be shared in one set of overlapping orbitals. Two types of bond, sigma bond, pi bond. The simplest molecule we can discuss in terms of valence bond theory is a hydrogen gas, H2. Hydrogen atom has one electron. So, orbitals of hydrogen atom is 1s. To form a bond, the orbital must overlap. Okay, so this is the maximum overlap of hydrogen. Sigma bond. Sigma bond occur when there is one bonding interaction that results from the overlapping of two orbitals. A bond can result from overlapping end-to-end of atomic orbital on neighboring atoms. Three types of sigma bond. Overlapping of two s orbital. Example, hydrogen. Overlapping of s and p orbital. One s orbital overlap with two p orbitals to form sigma bond. Example, hydrogen fluoride. Overlapping of two p orbital. So 3p orbital overlap with 3p orbital to form sigma bond. So example is Cl2. Atoms in simple molecules or ions such as hydrogen, hydrogen fluoride, nitrogen, and etc. use pure s and or p orbital in forming covalent bond. Example, hydrogen molecule. Overlap between 1s and 1s. Example, hydrogen fluoride. Okay. Hydrogen has one electron. So orbital that involve for hydrogen only one s. For fluorine, the valence electron configuration for fluorine is valence electron for fluorine is 7. So it's involved 2s and 2p orbital. Orbital 1s of hydrogen occupied by a single electron. One of 2p orbital of fluorine is occupied by single electron. So the single electron of hydrogen and fluorine are paired up and be shared between the two atoms. So 1s orbital of hydrogen overlap with 2p orbital of fluorine to form sigma bond. Example, fluorine. So, from the valence electron configuration, there is one of the 2p orbital is occupied by single electron. Another fluorine also one electron. So, the first fluorine have one single electron, so this electron will pair up. So, overlap between orbital 2p for the first electron and 2p of second fluorine will form a sigma bond. Example, show how the overlap of orbital in chemical bonding of hydrogen chloride. So the first thing, we write down the valence electron configuration. So hydrogen have one valence electron. Fluorine have 7 valence electron. So hydrogen has one single electron. Chlorine also has one single electron. So 1s will overlap with 3p to form sigma bond. So hydrogen overlap with chlorine to form sigma bond. Hydrogen is 1s orbital. Chlorine is 3p orbital. So share of electron. Pi bond, resulting from side-to-side overlap, has two regions of electron density, one above and one below the sigma bond axis. One pi bond holds two electrons that move through both regions of the bond. Pi bond is discrete rotation. Occur in molecule with double or triple bond. Example. So we have orbital p here, overlap. This p orbital overlaps side to side to form the pi bond. So this is the two region, one above and one below. Double bond consists of one sigma bond and one pi bond. Example, carbon dioxide. So for the double bond, it consists one sigma bond, one pi bond. Triple bond always consists of one sigma bond, two pi bond. Example, nitrogen. So this is the sigma bond. We have pi bond, two pi bond. Example, nitrogen. So this is electron configuration of nitrogen. So the valence electron at the 2p there are 3 single electrons. So we have here px orbital have 1 single electron, another p orbital, pz, have single electron, another one p orbital, py, single electron. So px we overlap with px, overlap head to head, end to end to form the sigma bond. And for the py, it will overlap side by side. Pz also will overlap side by side. So Pz overlap side by side to form the pi bond. Py also overlap side by side to form pi bond. So for N2 nitrogen, there is a sigma bond and 2 pi bond. As reminder, the formation of a sigma bond is formed by overlapping of s orbital, formed by overlapping of s and p orbital, formed by head-to-head overlapping of p orbital. The formation of pi bond formed by side-to-side overlapping of p orbital.